Alright, I'm going to give you a short demo of the plugin used to compute molecular surfaces and volumes using VMD2. I go to the plugins menu and I select volume, which opens the plugin window. We have several options to choose from. The main one is to select a file. I'm going to select one VFB.pdb, which is an antibody antigen complex. If you click load, you will see it in VMD. Otherwise, you see that we have to decide whether we include water molecules, we include L atoms, we include hydrogen atoms in the calculation. As you can see, an output directory has been preset to store all the files yielded by the calculation, and with this I run the calculation. It takes a few seconds and the result is sent to VMD. So we find the original structure and of course now the molecular surface in red. So if I deselect the structure, we see the boundary of the union of balls, the molecular surface, which consists of spherical caps, a spherical cap being bounded by circle arcs, which themselves are bounded by intersection points found at the intersection of three spheres. For example, here I have a spherical cap with 4 circle arcs and of course 4 vertices. If we navigate into the molecular surface, we see regions in blue, which are pockets corresponding to packing defects in the structure. They are pretty small here. As we shall see, there are 14 of them in total. And of course, I can move back, reintroduce the structure itself, and enjoy all the selection mechanisms provided by VMD. For example, select chain A, and now inspect more carefully the contributions of chain A to the molecular surface. If we move to the statistical section, we have the average surface area exposed by one atom, 5.5 squared angstroms, the average volume per atom, which is 23.3 cube angstroms. By the way, the atomic volume here is the volume occupied by the atomic ball in the solvent accessible model clipped by the Voronoi region in the Voronoi diagram of all atoms. It turns out the model has one connected component but 8 tunnels and 14 cavities, and of course we have the overall statistics per atom, which can also be inspected carefully using these histograms. As we noticed, there is one output directory which we can visit. So if I go there on my machine and if I take a look to the files which have been generated, so we have in fact a log file, log.txt. We have the VMD file corresponding to the boundary of the union in red seen in VMD, and we also have XML files in fact corresponding to records per atom and per residue, providing all the statistics displayed and that we have already discussed.